Hello everybody, myself Kullan Mukherjee. I am the Assistant Professor of Automobile Engineering Department of Dr. Sudhir Chandrasud Degree Engineering College. Today I am going to solve some numericals on differential manometer. This will be our lecture number 13. Our subject name is Hydraulics and Pneumatics. Subject code is HP. Module number is 1 and module name is Fluid Mechanics. Now coming to the lecture outcome, that after having this lecture, students will be able to understand the construction of differential manometer. Students will be able to determine the pressure difference between the 2 points in a pipe. So here is the first numerical on your screen. A pipe contains an oil of specific gravity 0.9. A pipe contains an oil of specific gravity 0.9. A differential manometer connected at the 2 points A and B as shown shows the difference in mercury level as 15 centimeter. Find the difference of pressure at the 2 points. Okay. So a pipe contains an oil of specific gravity 0.9. A differential manometer connected at the 2 points A and B, which is shows the difference in mercury level as 15 centimeter. Find the difference of pressure at the 2 points. So first of all, from this numerical we have to note down that what data has given in this numerical. So what are the data has given in this numerical? First of all, the data is given is that the pipe contains an oil of specific gravity is 0.9. Specific gravity of the liquid which is contained in this pipe, contained in the pipe A and pipe B, and that liquid having the specific gravity of 0.9. So that's why we can write here that S1 is equals to 0.9. Okay. Now rho 1 is the density of the liquid. Rho 1 is the density of the liquid. What will be the density? Density of the liquid. Density of the liquid is equals to specific gravity of that liquid and the density of the water, which I have already told you. So rho 1 will be here 0.9 into 1000, because 0.9 is the specific gravity of the liquid and 1000 is the density of the water. So density of the liquid will be here 0.9 into 1000. So if we solve this, then we will get that rho 1, that is the density of the liquid which is contained into this pipe A and pipe B, will be 900 kg per meter cube. Okay. So density of the liquid which is contained at the pipe A and pipe B having the density of 900 kg per meter cube. So here I am again repeating that how this rho 1 becomes 900 kg per meter cube, because at the first lecture I explained there that the density of the liquid is equals to specific gravity of that liquid and the density of the water. So specific gravity of that liquid will be here 0.9 and the density of the water is 1000 kg per meter cube. So that's why if we simplify this, then we will get 900 kg per meter cube, that is the density of the liquid. Okay. And also from this figure of the differential manometer, from the figure of this differential manometer, here small h is equals to 15 centimeter given. Why the small h is equals to 15 centimeter? Here you can see that is the differential manometer connected at the 2 points A and B shows the difference in mercury level as 15 centimeter. So mercury level here it is in the red color, it shows the mercury. So here so here is the difference between this mercury level is small h. Okay, the difference between the mercury level into these two limbs here can be denoted by small h, and small h is equals to here 15 centimeter. Small h is equals to here 15 centimeter. So here small h is equals to 15 centimeter. Okay, that data is given. Now above the small h, the distance of the center of the pipe A and pipe B from above the datum line xx will be here h plus x. Okay, so the distance between the center of the pipe A and pipe B from the datum line, the distance will be h plus x, where h is the difference between the mercury level into these two limbs. Okay, h is the difference between the mercury level of the two limbs. Okay, and x is the height of this center of the pipe, height of the center of the pipe uh, from the mercury level into the right column or right limb, from the mercury level into the right column or right limb. Okay, so we have to here find out the PA minus PB, because differential manometer is used to measure the pressure difference between the 2 points in a pipe. Okay, so differential manometer is used to measure the pressure difference between the 2 points in a pipe. So here this U-tube glass is attached with the two different pipes, that is pipe A and pipe B, and we have to measure the pressure difference between these two pipes, that is pipe A and pipe B. So we have to measure the pressure difference, that is PA minus PB, PA minus PB, and this will be on the condition, this figure is based on the condition when these two pipes are placed onto the same level, when these two pipes are placed onto the same level. Okay, when these two pipes are placed into the same level, then the PA minus PB we have to calculate. Okay, so pressure above the datum line in the left limb, pressure above the datum line in the left limb, what will be the pressure for the point A? For the point A, the pressure will be here PA. So here PA. Then again from the hydrostatic law we can say that the pressure is equals to rho gh or rho gz. So from here you can see that rho 1, that is the density of the liquid which is contained into this pipe, rho 1 g, and the total distance above the total distance of this point A from the datum line, it will be here small h plus x. So PA plus rho 1 G into H plus X. Okay. So PA plus rho 1 into G into H plus X. So this will be our equation number 1, that is the pressure above the datum line in the left limb or left column. Now coming to the similarly, we have to calculate the pressure above the datum line at the right limb or for the right limb or right column. Pressure above the datum line on the right limb, here again the pressure at the point B is PB, pressure at the point B will be here PB plus it is here you can see that is the red color signifies the mercury, which is the heavy liquid used in this manometer. So for this it will be rho g into G into H, rho g into G into H, where rho g is the density of the mercury, G is the acceleration due to gravity, and small h is the height of this mercury level above the datum line. Height of the mercury level above the datum line, that is xx is the datum line. Okay. Now PB plus rho g into G into H plus here again the liquid which is contained into this pipe whose specific gravity is 0.9. So here again rho 2 into G into X, rho 2 into G into X. Okay, so from here for the equilibrium condition we have to uh, equate the equation 1 and equation 2. Equation 1 is here PA plus rho 1 G into H plus X, and equation 2 PB rho G into H plus rho 2 into G into X. Why we are considering the rho 2? Because here we are trying to develop the derived formula, so that's why we are taking here the rho 2. Okay, so PA plus rho 1 G into H plus X is equals to PB into rho G into G into H plus rho 1 into G into X. Now here you can see that this is the rho 1, here it was here rho 2. to try to derive this equation or try to understand this equation properly. So that's why I am writing here rho 2. Okay. Now this rho 2 is equals to rho 1 because here already, because here in this numerical already mentioned that the pipe contains an oil of specific gravity 0.9. So that's why here rho 1 and rho 2 will be same because this pipe A and pipe B contains the same liquid. So that's why here it will be Pa plus rho 1 into G into H plus X. It is the equation number 1 is equals to Pb plus rho G into G into H plus rho 1 G into X. Okay. So from here Pa plus rho 1 G into H, if we multiply this rho 1 G with this term H plus X, then we can write that Pa plus rho 1 G into H plus rho 1 G into X is equals to Pb plus rho G into H plus rho 1 G into X. Okay. So Pa minus Pb. So shift this term opposite of the equal sign. So it will be getting negative. So Pa minus Pb is equals to rho G into G into H plus rho 1 into G into X minus here this rho 1 G into H will be shifted here, and again here this plus rho 1 Gx again it will be shifted into the opposite sign, opposite of the equal sign, then it will be again forms a negative sign here, rho 1 Gx minus rho 1 Gx. So plus rho 1 Gx and minus rho 1 Gx will be cancelled out. So remaining part will be here Pa minus Pb is equals to rho G into G into H minus rho 1 into G into H. Okay. So from here if we take the common G into H, if we take the common GH from here, then we will get that Pa minus Pb is equals to G into H into rho G minus rho 1. Now Pa minus Pb is equals to, just put the value of all the values into this equation, just put all the values into this equation. G is the acceleration due to gravity, that is 9.81 meter per second square, into small h is given as 0.15 into rho g is given as here 13,600 kg per meter cube minus rho 1 is 900 kg per meter cube. So if we solve this, then we will get that the pressure difference between the 2 points in a pipe A and B, that is Pa minus Pb, is equals to here 18,688 Newton per meter square. Okay. So Pa minus Pb, that is the pressure difference between the 2 points in a pipe A and pipe B. The here will be the 18,688 Newton per meter square. Okay. Now coming to the next problem, that is a differential manometer is connected at the 2 points A and B of the 2 pipes as shown in the figure. I will show you the figure later on. So a differential manometer is connected at the 2 points A and B, the 2 points as shown in the figure. The pipe A contains the liquid of specific gravity 1.5. The pipe A contains the liquid of specific gravity 1.5, while the pipe B contains the liquid of specific gravity 0.9. Okay. So the pipe A contains the liquid of specific gravity 1.9, while the pipe B contains the liquid of specific gravity 0.9. So here from this line you can conclude that in this type of numerical there are two different liquids are used. There are two different liquids are used, and their pressure difference we have to measure. Now let's see what is given in this numerical. Okay. So specific gravity 1.5, while the pipe B contains the liquid of specific gravity 0.9. The pressure at A and B is given as 1 kg force per centimeter square, that is kgf per centimeter square. So the pressure at the point A and B are 1 kgf per centimeter square or 1 kg force per centimeter square, and at the pressure at the point B will be here 1.8 kgf per centimeter square, that is 1.8 kg force per centimeter square respectively. Okay, so find the difference in the mercury level in the differential manometer. So we have to find out the difference in the mercury level, of the differential manometer. Okay, and now what data has given into this numerical. First of all, we have to note down all the data which is given into this numerical. So first data is that a differential manometer is connected at the 2 points A and B of the two pipes as shown in the figure. I will show you the figure. The pipe A contains the liquid of specific gravity 1.5. The pipe A contains the liquid of specific gravity 1.5. So S1 is equals to here 1.5. Here we are considering that S1 is equals to 1.5. So rho 1 is equals to here 1.5 into 1000 is equals to 1500 kg per meter cube, because I have already told you that density of the liquid is equals to specific gravity of that liquid into density of the water. Then we will get the density of the particular liquid. Okay, so rho 1 is equals to 1.5 into 1000 is equals to 1500 kg per meter cube, that is the density of the liquid. Now S2 is the liquid which is used at the pipe B. Okay, now the pipe A contains the liquid of specific gravity 1.5, while the pipe B contains the liquid of specific gravity 0.9. So the pipe B contains the liquid whose specific gravity is here 0.9. So again we have to calculate the density of this liquid. So rho 2 is the density of this liquid which is contained at the pipe B. So rho 2 is equals to 0.9 into 1000. So ultimately it will be 900 kg per meter cube. Okay, 900 kg per meter cube. So rho 1 is 1500 kg per meter cube and rho 2 is 900 kg per meter cube. Now again PA is given as 1 kg force per centimeter square. 1 kg force per centimeter square. So 1 kg force is equals to 9.81 Newton. 1 kg force is equals to 9.81 Newton. So that's why 1 kg force, instead of the 1 kg force, we can write that the 9.81 Newton. Okay, and to convert the unit from the Newton per centimeter square to the Newton per meter square, it will be multiplied by the 10 to the power 4. So after all, the PA, the pressure at the point A, will become 9.81 into 10 to the power 4 Newton per meter square. Okay, now coming to the PB, that is the pressure at the point B is 1.8 kg force per centimeter square. PB is the 1.8 kg force per centimeter square. So similarly, to convert the unit from kg force to the Newton, then again we have to multiply this term with the 9.81. So it will be here 1.8 into 9.81, and again we have to convert the unit from centimeter square to the meter square. So then it will become 9.81 into 1.8 into 10 to the power 4 Newton per meter square. And here we have to measure the small h. Here we have to measure the small h, that is the difference between the mercury level of the two limbs of the manometer. Okay, difference between the mercury level of the two limbs of manometer. So here the two pipes are placed into the different level in the manometer. Okay, so here just consider that the two pipes are placed into the different level in the manometer, and we will get that pressure above the XX datum line on the right limb. Pressure, okay, just look at this figure. Here you can see this is the figure is given as here. That is the pipe A, and that is the pipe B. Okay, and this is our datum line. XX is our datum line, or at your zero atmospheric pressure level. Okay, and here you can see that this is the uh, mercury level into the left column, and this is the another mercury level at the right column of this manometer, of this differential manometer. So small h is the difference between the mercury level of this manometer. So here it is the small h manometer. Here it is the, sorry, here it is the small h meter. Here it is the small h meter, that is the difference between the mercury level of the two limbs of the manometer. Okay. Now above the h, the pressure at the point B, the point B distance is 2 meter and point A is distance is 3 meter. Okay. So above the h, the distance at the distance up to the point B is here 2 meter and distance up to the point A is here 3 meter. Okay. So now we have to calculate the small h. We have to calculate the small h. Okay. Okay. So now here first of all, pressure above the XX datum line on the right limb. XX datum line. Okay. Pressure above the XX datum line on the right limb. So PB plus rho 2 G into H plus 2. PB plus rho 2 G into H plus 2. Okay. So PB means, here you can see that, here you can see in this figure that above the XX datum line, the pressure onto the right limb. Above the XX datum line, the pressure onto the right limb will be here PB, that is the pressure at the point B, PB, plus rho GH. This is the actual formula of the pressure from the hydrostatic law, what we have already derived. So rho, that is here the here it will be rho 2, here it will be rho 2. Okay. So it will be here rho 2 into G into H plus 2, because above the datum line and up to this point B, the distance will be here small h plus 2. So rho 2 into G into H plus 2. So here you can see that PB is equal PB plus rho 2 into G into H plus 2. Okay. Now PB, what is the pressure at the point B? Pressure at the point B is given as 1.8 kg force per centimeter square. It is given, it was given. Okay. Now now we convert this unit from kg force per centimeter square to the Newton per meter square. So that's why it will become now 9.81 into 1.8 into 10 to the power 4 kg Newton per meter square. This is the pressure. This is the total pressure PB. Okay. Now rho 2 G into H plus 2. Rho 2, that is that we have already calculated, that here you can see that rho 2 is here. Rho 2 is 0.9 into 1000. So here it will be 900 kg per meter cube. So 900 into G, that is 9.81 into H plus 2. Okay. So after solving this, we will get 1,76,580. 1,76,580 plus 8,829 into H plus 17,658. So if we solve this term, then we will get 1,76,580 plus 8,829 into H plus 17,658. If we solve this, then we will get 1,94,238 plus 8,829 into A. That will be our equation number 1. So pressure above the XX datum line on the right limb will be here 1,94,238 plus 8,829 into H. That will be our equation number 1. Now similarly, pressure above the XX datum line on the left limb. Here you can see at the left limb, the pressure above the datum line, pressure above the XX datum line onto the left limb or left column of the manometer. So here the pressure due to this point A will be here PA, first of all PA, plus it will be rho G into G into H. Okay. Rho G into G into H plus rho 1 into G into H plus 5, because above the H, the total height up to this A, because the distance between the center of the pipe A to the free surface of the mercury level at the left limb will be here h plus 5, because 3 plus 2 is 5, so h plus 5. So here you can see that is the h plus 5. So Pa plus rho g into g into h, that is the total pressure due to the mercury which is used as a heavier liquid in this differential manometer, plus rho 1 into g into h plus 5. So here Pa is 9.81 into 10 to the power 4, plus rho g is 13,600 into 9.81 into h, plus rho 1 g into h plus 5. So it will be here uh, sorry, this would not be the h plus 5, it will be here only 5, because up to this it was taken as the mercury. Up to this point, small h point, it was taken as mercury, and above the mercury the liquid which is filled within this pipe A, and this liquid having the specific gravity of 1.5. Okay, so it will be here rho 1 g into 5, rho 1 g into 5, because the total height is here 3 plus 2 5. Okay, so uh, it will be here instead of this h plus 5, it will be here rho 1 into g into 5. So instead of this term, here you can see that, so instead of this term, we have to write that rho 1 g into 5, rho 1 g into 5. So if we now simplifying this, then we will get 9.81 10 to the power 4, because Pa is the pressure at the point A, which is given in this numerical as 1 kg force per centimeter square. So that's why it will be 9.81 into 10 to the power 4 Newton per meter square, plus rho g into g into h, where rho g is the 13,600, where rho g is the density of the heavy liquid or mercury, g is the 9.81, and h we have to calculate. Okay, plus rho 1 g into 5. So rho 1 will be here 1500, g is 9.81 and h is 5. So after simplifying this term, then we will get 98,100 plus 1,33,416 into h, plus 1500 into 9.81 into 5, that is equals to 98,100, plus it will be here 1 is missing here, it will be here 1,33,416 into h, plus 73,575. So it will be here 1,71,675 plus 1,33,416 into h. This will be here 1,33,416. So this will be our equation number 2. So if we equate the equation number 1 and equation number 2, then we will get that 1,71,675 plus 1,33,416 into h. Here again it will be 1. Okay, so 1,33,416 into h is equals to 1,94,238 plus 8,829 into small h. So if we solve this, then we will get 1,33,416 into h minus 8,829 into small h is equals to 1,94,238 minus 1,71,675. So from here we can calculate that it will be here 1,24,587 into h is equals to, again instead of this 18,563, it will be here 22,563. 22,563. So it will be here small h is equals to here ultimately 22,563 divided by 1,24,587 is equals to 0.181 meter. Okay. So that is the difference between the mercury level in the in this manometer. So small h is equals to 0.181 meter. Okay. So now there is a one practice module which you have to solve in the above figure. In the above figure, if the liquid used in the pipe B having the specific gravity 0.7 and the pipe A contains water and all other data remain same, then calculate the small h. The all other data will be remain same. So the liquid which is used at the pipe A having the specific gravity 0.7 and this will be the pipe B. Pipe B contains the liquid whose specific gravity is 0.7 and the pipe A contains the water and whose specific gravity is 1 and the density is 1000 kg per meter cube. So and the other data will be remain same. So it will be here small h, it will be 2, it will be 3. Other data will be remain same. So within this you have to calculate the small h. So this is the practice module for your purpose to solve this numerical. Okay. So here I am going to end my lecture. Thank you. Thanks for listening my lecture. Thank you.